In this video, we'll be looking at the midsegments of triangles, and once we know what the midsegment of a triangle is, we'll be talking about what that line does to the measurements in our triangle. So let's get a triangle on our page. Alright, so a midsegment of a triangle is a segment, a line segment, with endpoints that are midpoints of two sides. So let's get those endpoints here. So we have one side here, the midpoint of that side is about right here. Of course, you would be using a ruler, unlike me. And the other side here, let's look at that. The midpoint is around right here. So the midsegment has endpoints that are the midpoints of those two sides. Something else that's special about the midsegment is the fact that it will be parallel to the third side of our triangle. Now, how many midsegments do you think there are in a triangle? Well, if you said 3, you are correct. So if we have a triangle here, I'll just redraw it here. If we have a triangle here, there is a midsegment that's parallel to the one at the line at the bottom, the segment at the bottom. There is one parallel to the segment on the left, and there's one parallel to the segment on the right. So there are 3 midsegments in every single triangle. Okay, so we're going to talk about something that you probably already know about the midsegment, and we're going to add a little bit more. So recall that J is halfway between F and H, which means what do we know about FJ and JH? Well, hopefully you remember that since that's a midpoint there, that those lines must be congruent to each other. So I'll actually write that down so we do not forget that FJ is congruent to JH. Alright, which makes sense again because J is right in the middle of that segment. Alright, what else do we know? Well, you probably recognized also that GK and KH will be congruent as well. Let's write that down. GK is congruent to KH. And again, the reason for that is because that point at K is right in between the entire thing. It's halfway there, the midpoint. So that has to be equal to that in measure. All right, but what do you probably not know? You may not know that this line here is always going to be half of the line that it's parallel to. The measure of this line, that parallel line here, or midsegment, is always going to be half of the line it's parallel to. So let's write that down. This is the one you may be new to. JK is equal to half of FG. And that is kind of neat, I think. Alright, so that is called the triangle midsegment theorem. Okay, so here we have an example where we get to practice our knowledge of midsegments. So we know, according to the question, that XY is a midsegment and so is XZ. So let's go ahead and start by finding the first thing that they ask for, which is XZ. Alright, so you may recall that the midsegment, which is XZ in this case, is always going to be half the length of the line, the side that it's parallel to. So our midsegment XZ will be half the length of RT, and that's very useful to know. So XZ equals half RT. Okay, and we do know what RT is. RT in this case, as you can see, is 13. So XZ is equal to half of 13, which gives us that XC then is 6.5. Alright, so now we can go ahead and find the next thing that they ask for, which is ST. So, ST is located here. It is not a midsegment, it's actually a side of our triangle. However, we do know the midsegment which it's parallel to. The midsegment, XY, that it's parallel to is 7, and they're asking for this. And we remember, hopefully, that the midsegment is half the length of the line that it's parallel to. So that means that XY is a half of ST. And we know XY. We know that XY is 7, so that's a half of ST And now we can go ahead and multiply both sides by 2. So we can get rid of this and isolate, or ST. And we get that ST is 14. All right. So that is our second thing out of the way. And now all we have to do is find our angle RYX. So let's mark this on our diagram. Angle RYX is here. So I'm going to put in a little angle marker for RYX. All right. Now, you may recall from a previous unit that if we have two parallel lines, so here's a line, here's another line which is parallel, and it's cut by a transversal, we create certain angle relationships. Let me sketch this off to the side so it looks a little bit more familiar. All right, so we create certain angle relationships. So in this case, the angle that we know is here, the angle that we are looking for is here. They're both inside or perpendicular, or parallel lines, which means that they're interior angles and they're on opposite sides of the transversal, which means that they're alternate interior angles. So let's start writing here. So in order to find angle RYZ or YX, we know that they're alternate interior angles, which means that they are equal in measure to each other. So angle YXZ is congruent to angle what we're looking for, the angle that we're looking for, which is RYX. So the measures are equal. So I'm writing all the official stuff here. The measures are equal to each other, RYX, which means that since we know the measure of the first one is 24, then we know that that's also the measure of angle RYX. They're actually equal to each other. All right, so we found everything we need to know, and the mid-segment theorem helped us do it all.